are 4 formulas I gave you yesterday relating the polar coordinates to the rectangular coordinates. Can someone give me one of the 4? We're going to write them up at the top so that we have them to use. What's one of them?
Theta is equal to the inverse tangent y over x.
Okay, and I'm going to write it as this. Tangent of theta is equal to y over x. All right, that's one of the 4. Give me another one. Hint, hint, hint. They were all written on the board a second ago. And you should have them in your notes 1 page over. Not on the half angle. Okay. X squared plus y squared equals r squared. Okay. And 2 more. Yep. X equals r cosine theta. And last one. Y equals r sine theta. Okay. So what our objective is for today, so just so you understand, we are going to change, yesterday we were changing our coordinates from polar to rectangular, so we were changing our x's and y's to r's and theta, and our r's and thetas into x's and y's. Now, instead of it just being points, we're going to do it with equations, okay? So, if we have equations like you see here, in example 1 with r's and thetas, we want to change all the r's and thetas to x's and y's, okay? And when we go the other direction, we want to change all the x's and y's to r's and thetas. That's going to be our overall objective, okay? When we look at these examples, you can use anything in your tool belt, okay, as long it is legal in algebra. For example, I can multiply both sides, I can divide both sides, I can square both sides. I can do anything as long as it follows our rules of algebra, okay? Now, our objective is to get something from up here so that we can substitute. That's our goal, is we want to substitute. And then that will change things from the r's and thetas to the x's and y's, okay? So, looking at example number 1, we have r equal to 3 sine theta. We have to change that to x's and y's. Any ideas? What do you want to do?
I would square each side to start.
Okay. Now, I like what you're thinking, okay? Don't write this down, but if I do that, okay, I would have r squared, and then I would have a 3 sine theta quantity squared. All right. Now, you can now change your r squared into x squared plus y squared, so you're good, okay? But would we be able to change our theta into an x or a y?
You can change it into tan. That's why I said theta was equal to tan inverse tan y over x. So I
Oh,
into that.
no, we don't want to necessarily do that.
Okay.
Okay, and so here's what eventually, like I'm trying to get at with the example that you have, is if we want to change the sine theta, we need an r. Do we have an r with the sine theta using the idea of squaring both sides?
No.
No, so we're not going to go this route.
So you multiply by
But I like the fact that you were thinking that. So Jackie.
You could plug in for in the y equals r sine theta, or the x equals r cosine theta. You could plug in r for, you could plug in like 3 sine theta for r, and then you get r equals, or x equals r 3 sine theta cosine theta.
Okay, so you want to plug the r in where?
Like,
Next to the...
like either the cosine theta or the sine theta.
Okay, so if we went that route, okay, so just to explain what she's saying, is let's say we took this and we plugged it in here, okay, for the r. Now you've got x. All right, that's a good start, okay, and then you would have, what? A 3 sine, oh no, we're plugging r in there. So you would have what, 3 sine theta cosine theta. So kind of like what you were saying, you know, we got rid of the r squared using your idea, but then we still have the theta. So the only difference here is we're not able to get rid of both. Okay, so we're not going to go that route. This one's a little bit tricky. We'll give it one more try and then I'll tell you what to do on this. Okay? What do you think?
Multiply each side by r,
Ooh.
because then you get r squared equals 3 the r sine theta, you change r sine theta to y, so you have r squared equals 3y, and you have x squared plus y squared equals 3y.
Ding, 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 ding. Winner, winner, chicken dinner. Good job. All right. So he said multiply both sides by r. If you do that, r times r becomes r squared. Are we able to change r squared into x's and y's? Yes, because now r squared becomes x squared plus y squared, right? Okay? Then, if we multiply the other side by r, now we have 3r sine theta, and he said change the r sine theta into, so now we have equals 3y. Do we have any more r's, and do we have any more thetas? No, we're done. Okay? You do not need to get the y by itself and try and put it in slope-intercept form. You don't need to get the x by itself. You don't need to do anything like that. Your overall objective is basically just get rid of the r's and thetas, change everything to x's and y's. Yes?
But since you're squaring the r,
We're not squaring the r. We're multiplying by r. That's completely different. Okay? Because if we squared both sides, that would be Joe's idea. That means we wouldn't get an r on this side. But we multiplied both sides by r. Got it? Okay. So, example 2. Ideas.
Multiply by r again.
Yeah, let's use the same concept. Let's multiply this by r, giving us an r squared, and let's take all of this and multiply by r. So now we've got r squared, and, reminder, we're going to distribute the r to both, giving us a 5r cosine theta plus 2r sine theta. Now what?
Convert the cosine theta.
Okay, so Jason wants to change the r cosine theta into,
5x.
so he wants to change this into 5x, because that's the same thing as x. What do we change the r squared into? Oh, I was asking the r squared, but you're right, this is going to become 2y because of the r sine theta. What about the r squared? X squared plus y squared. And you can just leave it like that, okay? Doing okay? All right? And just FYI, like, you know, if you start looking at some of these equations, they're all going to end up being a little bit different. Like this one is what, you know, some of them are going to be like parabolas, some of them are going to be circles, some of them are going to be ellipses, some of them even might be linear, okay? All right, example 3. This one's tricky.
Hey, what's the answer for our example 2?
You see it?
Yes.
Okay. Example 3. You got an idea?
no, this is like a lot like for like sine and cosine, right? You're just
Yeah,
plugging stuff in
A little bit, yeah. Anybody else? All right, so this time instead of multiplying by r, and think about this, if we only multiplied by r, what would this r squared become? R cubed. Do we have a way of changing r cubed? No. But instead, I can multiply both sides by r squared. Now this is why. Just a little caveat to this, okay? You don't have to write this down. I'm going to come back to it here in a second. If I asked you what 5x times 2x was, what would you say in simplified form? 10x squared. All right, so this is what we're going to do. We're going to take our 10x squared and we're going to split the x up into 2 pieces. That's what we're going to do, just so you understand where we're going with this, okay? All right, to show what I mean by that, I am going to multiply both sides by r squared, okay? Now, I can write r squared as r to the 4th, or I can write it as r squared squared. And I'm just going to do it that way because what can I change r squared to? How about x squared plus y squared? But if I have it as r to the 4th, then you're probably, some people might be confused on what you change it to. So we're going to change this to x squared plus y squared, okay? All right? Next, okay, on this side, since I have two r's, I'm gonna put one of them with the sine and one of them with the cosine. And so I am gonna have 2r sine theta times, not plus, that's why I'm allowed to do this, 3 cosine theta. And so it's like my analogy of a second ago, oh, and I forgot to write in the letter R here, okay? Where it's like 2x times 3x would equal a 6x squared, so the r times the r over here is going to be an r squared. But this allows me to change the r sine theta to x and the r cosine, sorry, the r sine theta to y and the r cosine theta to x. So this becomes 2 times 3, which is 6, and then xy.
Wouldn't if you carry over the r squared to both sides, wouldn't there still be an r left over? Because only r sine theta is equal to x.
All right, so you have two r's, right? So I'm splitting up the r's, one to the sine and one to the cosine. So I'm using both of them. So you don't have an extra one left over.
That makes sense.
Okay, and so now that allows me to change this to a y and this to an x. Okay? All right, example 4. I'll give you a huge hint. We're not multiplying both sides by r or r squared. We're going to do something different this time. What are we going to do? Ooh, I like it. We're just going to square and square, giving us r squared equal to 81. What can we change r squared to? X squared plus y squared equal to 81, and we're done. And what shape is that if we were to graph it, just out of curiosity? Circle, okay? Because x squared plus y squared equals r squared, okay? All right, example 5. Ideas. What do you want to do?
I would say tangent theta is equal to y over x, and then multiply each side by r.
Okay, all right, so I like what you're thinking, okay? But here's what I want you to be aware of, okay? So if we multiplied this by r to get an r tan theta, just out of curiosity, is that equal to r sine theta over r cosine theta? Is that true? No, because what would happen with the two r's?
They cancel.
All right, and so if we only put r in one of the spots, are we able to convert the other one into an x and a y? No, because this is a y, or this r sine theta we could change to a y, but we wouldn't be able to change this into an x. Okay, so I like the way you're thinking, but it wouldn't work out. So, other ideas?
Can we change the tan theta to y over x?
2y over x.
No, just like the y over x.
Oh, okay, we can do that, all right. So r is equal to 2 and then y over x, we can do that.
Yeah.
Okay, but we still have an r that we have to get rid of.
Yeah.
So do you have an idea?
Isn't the r equal to the square root of x squared plus y squared?
Okay, but how can we do this without having a square root?
Right, you just square the other side.
Okay, so how about we just square both sides from the beginning, and then we don't have to do the square root thing. Okay, so we're going to use Lauren's idea. We're going to square both sides, okay? And now r squared becomes x squared plus y squared. And when I square this, 2 squared becomes 4, y squared becomes y squared, x squared becomes x squared. Okay? And then now we don't have a square root. All right? All right, so big idea. You got to get rid of the thetas and the r's. You got to change everything into x's and y's. You don't have to worry about getting y by itself or x squared by itself, anything like that. Okay? You don't have to worry about that. Questions? All right, now on the other side, we're going to go in the exact opposite direction. Now they gave us x's and y's, and now our objective is to change this into r's and thetas. Okay? Now, different from the front side. Now they want you to get r equals r squared equals r cubed equals. So now, after substituting, plugging and chugging, all that stuff, they do want you to get the r by itself. All right, because if you look back to the previous side, you know, like our other page of the notes, all of them were R equals, R equals, R equals. So they want you to get it in that form, okay? All right. First one, not too bad. What can we do?
Literally plug in X and Y.
All right, what are we going to plug in for X and Y?
R cosine theta and R sine theta.
All right, so we're going to change this into a 7 times R cosine theta minus 3 times R sine theta equal to 5, okay? The hardest part is done, and what I mean by that is you did the converting, okay? Now your objective is just to use your algebra skills and get R by itself. Ideas?
Oh,
Divide, what? I'm not going to use the word divide, I would use a different word, but what? Factor out what?
R.
R. So now we've got R times 7 cosine theta minus 3 sine theta equal to 5. And now we can use your word. Divide. And R is now equal to 5 divided by this whole thing of 7 cosine theta minus 3 sine theta. Okay? Questions there? All right? Example 2. Keep doing the same concept. The only difference comes down to getting that R by itself. So, we're going to change the X into R cosine theta quantity cubed. We're going to change the Y into R sine theta quantity squared, which becomes R cubed cosine cubed theta and R squared and sine squared theta. All right, our goal is to get the R's on one side, everything else on the other side. Ideas? Jackie?
Divide R cubed by R squared.
Okay. She wants to divide by the R squareds, that cancels. Divide by the R squared over here, and what does that simplify down to be? Just plain old R. Okay, that's good.
And then divide cosine cubed, or
Okay.
sine cubed by cosine cubed.
All right, so divide by cosine cubed. And so now R, all by itself on the left, is equal to a sine squared theta over a cosine cubed theta. All right, so if you got to there, I'd be pretty happy. You can take this a step further, though. Any ideas? Yes?
Tan squared theta over cos theta.
Okay, so he's going to do the following. I'm going to write this out step by step just so people can see where you're going with this. Okay? All right. All right, so he sees that there are two sines and there are two cosines, and he remembers sine divided by cosine is tangent, so he wants to change this into tangent squared. So R is equal to tangent squared theta. And then since we're doing that, why don't we go ahead and change the 1 over cosine theta to secant theta. Okay? If you got to here, though, that's really good, okay? I just want to show you that sometimes you might see it written like that. Make sure you understand where they're going with that, okay? How are we doing?
Good.
Just one more, or you want to go through both of them?
One.
Both?
Full.
Okay, all right.
Yes.
We got time? All right. So, example 8. You want to try one on your own?
Not this one.
Oh, okay. Why?
I've already started trying to do this on my own.
So what did you do?
First thing I did was plug in for, well, at first I tried moving the 5 over and then squaring, or multiplying by xy, but then I stalled.
Okay,
So I scratched out and tried again, and just plugged in x and y there, now I've stalled again, so.
I assume when you meant you plugged in for x and y, you did this.
Yeah,
Okay,
and then I divided
so
by 5.
your goal here is to get the r by itself,
Yeah,
okay? Now, it's different than the last one that was similar to this because I had a plus sign. These are all multiplying. You're still gonna kind of use the same concept, though. Any ideas? What do you wanna do?
5 over.
All right, we're gonna divide the, 5 over, but at the same time, what else can we divide over? Do you see that 5 is multiplying by r, which is multiplying by cosine, which is multiplying by r, which is multiplying by sine? So if they're all multiplying, what can we divide by?
5 cosine theta sine theta.
And if we do that, what are we left with?
R squared.
2 r's. R times r, which is r squared. You're correct. And then equal to 2 divided by 5 cosine theta sine theta. Okay? So don't overthink it. It's, you know, if you wanted to, you could take it a step, you know, in the middle and put the r's together and writing it as r squared and then dividing by everything, but I think you see that you could just do it all at once.
Is the answer really just the square root of that?
No, you're not gonna write it as the square root. We don't want square roots, so remember at the beginning I said, you can leave it as r squared, r cubed, you can leave it like that. Don't do square roots, okay?
I had that, but I was wondering.
Are you good? All right, so last one then, okay, for this, you are given, you know, your x squared and your y squared. So same concept that we've been doing, change the x squared to your r cosine theta squared, which I'm just gonna go ahead and write as r squared cosine squared theta, minus 6 times r squared sine squared theta, equal to 6. All right, ideas. This time you have a minus sign, before you had a times sign. You did have a plus sign earlier. So what do you want to do?
Factor out r squared.
Jackie, what do you think? You agree? All right, so we're going to factor out an r squared, leaving a cosine squared theta minus a 6 sine squared theta equal to 6. And then how are we going to get the r squared by itself? Just divide, and we're done. R squared is equal to 6 divided by cosine squared theta minus 6 sine squared theta. Okay? All right, so you're going to, you know, by practicing this a lot, you're going to really get to know that r is equal to cosine, you know, r cosine theta is equal to x and r sine theta is equal to y. Okay, you're going to practice that a lot. Okay?